What's up, everyone? My name is Jeff. This is Jeff Brown Tech. We are continuing on in our PowerShell command line to scripting course. If you're just finding this video, go check the video description for a link to the full playlist. It's a mix of new and old videos where I talk through different topics on working from the command line out to writing your own PowerShell scripts. This is module 3, where we're going to start talking about parameters. This one may be a little shorter just because I've done a lot of videos about parameters, and I'll include those in the playlist after this one. This will be more of an introduction and just a couple of tips and tricks. And of course, a challenge at the end for you to get started writing functions and how to think about them inside of your scripts. Here we are out in this code. This code is also available out in GitHub. That link will be down in the video description also. Let's go ahead and go through this introduction on this lesson, and then we'll dive into our first topic. Here in module 3, where we're talking about script parameters inside of PowerShell, we'll learn about why parameters are important when you're writing your scripts to make them more dynamic and user-friendly. A couple of things we'll talk about is defining them with your param block, creating mandatory and optional parameters, using input with your built-in attributes, using switch parameters, handling arrays and hash tables, and improve usability with aliases and positional parameters. Our first lesson is going to cover creating script files. So far, I've been using Jupyter Notebooks to allow you to interact and do some of these exercises right here inside of VS Code. However, Jupyter Notebooks don't support writing parameters. This means you will need to start creating PS1 files if you want to work through some of these exercises. Then we'll jump into defining and using script parameters, validating input, working with your switch parameters, some miscellaneous things about parameters. And as usual, at the end of each lesson, we have mini exercises for you to complete, and then our challenge at the end. Let's go ahead and close this out, and let's open up the first one talking about creating script files here. Just in case you're unfamiliar with creating PowerShell script files, they do end in the file extension PS1. And moving forward inside of this course, we're going to focus more on writing and running script files instead of using our Jupyter Notebooks. First thing you want to make sure you have is a text editor. I recommend Visual Studio Code. That's what we're in right now. Microsoft provides a PowerShell plugin, which makes writing script files just so much easier in anything you're doing with PowerShell. There's also PowerShell ISE. It is built into Windows. You can still write PowerShell scripts in there and everything, but it's missing a lot of the autocomplete and syntax checking and everything you might find inside of VS Code. But if you're on a server and you're not allowed to install VS Code, just know it's there and you can still use it. And always, there's Notepad if you just need to make a quick edit. We'll create a script file from the viewpoint of Visual Studio Code. Right now I'm in full screen mode, so let me exit out of there. What you'll want to do is come up to File and do a new text file. It will ask you if you want to select a language. You can go ahead and select that. And if you start typing in PowerShell, what that is going to do is down here in the bottom right, it's going to recognize it and start giving you PowerShell syntax for it. You can also see that immediately opens up a PowerShell terminal for us to use right below our file here that we're working on. And it opens up in my current directory of where this Visual Studio Code was open in. Finally, if I need to go save this, I can go save or save as. It automatically puts me into this directory here. I'll just say my first script. You can add PS1 here if you want to. It'll automatically do that if you don't though. And we can see right over here, my first script, I'm open in this directory and it's available. I did cover this in the introductory lesson. If we go into our extensions here and we search for PowerShell, also recommend coming in here and installing this extension from Microsoft. It'll give you syntax highlighting, some built-in code snippets, IntelliSense. Again, makes writing PowerShell scripts super easy. For example, if I were to come in here and start typing something like new item, we can see it auto-completes for me. And then if I hit space and dash, we can start, it will bring up all my list of parameters that are available for this command. It'll also do some highlighting for you for best practices. If I were to do something like get item and then go right into here, set item and go like this, we can see a little curly line right here underneath our % here, which we know is an alias for each. We go highlight over here, it just says it's an alias of for each object. It can introduce possible problems, make scripts hard to maintain. Consider using the full context. So this again is where we'll cover this a little bit more, but it's suggesting best practices to you as you write your PowerShell scripts. All right, let's close out of this. I do not want to save my changes here. In fact, let's go back over here and I want to delete this out of here. But again, that's just the quick, easy way Open up Visual Studio Code, have the extension, create your file. If you don't set the language, it should automatically recognize that that it's PowerShell and to start giving you syntax highlighting and everything that way. Open up a PowerShell window down here for us. We want to try a command or run a script or anything like that. Within PowerShell, there is also execution policies. Windows may prevent you from running PowerShell scripts for security reasons. You can do different things like getting your execution policy and setting it. If you want to run set execution remote sign and scope it to your current user account, it should allow you to change it. Setting it to remote sign, I do put a note here, allows you to run locally created scripts and will protect your system from unsigned downloaded scripts. That's pretty safe there. If I hit Control J and bring this back up here, let's see what my current system is set to. I actually don't know. We can run git execution policy. Currently set to bypass, so I just have it wide open here. But we also have set execution policy. And if we do execution policy, and we can tab through all signed, bypass, remote signed, restricted, a couple of different options there. I'll include a link to what those are. I'm not going to cover it here currently, but that is how we can double check that just in case you're writing scripts and it doesn't allow you to run it or it gives you a warning about it. And if you're not familiar with command prompt, you'll want to use cd, or you can use set location. That's the PowerShell command for it. I think cd is probably an alias. That means change directory, go to where your script is, and then you can execute a script. You'll want to prepend it with the dot and a backslash, and make sure you put in the full script name. You can also use PowerShell.exe, and it has a parameter of file. Put your file name in here. That's less common. If you're in a PowerShell console window, you can just run your script file like this, and we'll start seeing examples of that as we start moving through the rest of these lessons. All right, that does it for just a quick introduction on PowerShell scripts. We'll see this in action as we move through everything more. Let's go ahead and close this out, and let's start talking about our first lesson here of defining parameters. What exactly is it a parameter? If you've been working with PowerShell, you've been working parameters, whether you know it or not. They allow you to provide input values to the script or function that you're running to give it context and to act on that information. Parameters enable you to provide that dynamic information so you don't have to hard code it within your scripts. If you hard code something in a script, you then have to go back and change it each time and edit it in order to run it again in another situation. Parameters allow you passing that information into. Let's go back to lesson 2, actually, where we were looking at our number game, and I did the number game bonus here. Let's scroll back up to the top. Let's take a look at a couple of things here. I set difficulty to medium. I hard coded that, but the difficulty level is perfect here for a parameter. I could have a parameter of difficulty and set values for, easy, medium, or hard. That way, each time I ran the script, I could change that value and switch it up without coming and editing the file. I didn't do it here because we hadn't learned about parameters yet, so I just set the value. I wanted to create these exercises using information you know at the time instead of trying to jump ahead. Again, why should we use parameters? It increases reusability. You can use the same script and put it into different scenarios. Enhances your readability. Scripts become easier to understand when input values are defined explicitly rather than buried inside the code. We'll see what we mean about that a little bit later. And improves automation. You can write a script and use it yourself on your system. You might not think that's a big deal. You can go change values within the script yourself. However, if you want to put it inside of automation, inside a scheduled task, or have it trigger through an API or something like that, being able to set values dynamically through parameters is what automation is all about. Let's go into how we define parameters inside of our PowerShell scripts. We have a keyword here of param and an open and close parentheses. And inside our parentheses here, we will use different blocks to declare our parameters. Your param block here has to be at the top of your script and placed before any executable code. You can't put it at the middle. You can't put it at the bottom. It has to be at the top right there before your code that you have inside the script. Within our param block, we have 2 fundamental components. We have, again, the param keyword and open and close parentheses, and then a parameter name declared using a $, just like we have with our variables. Parameters and variables, you can pretty much think of them as the same thing. It's information. It holds information that you'll use inside of your script. Let's take a look at a very, very basic parameter definition here for a script. We have param right here. This is all of our parameters. And we have 2 things in here. We have $name for one parameter and $age. This is the bare minimum you need to define parameters, param block, and then the name of the parameter. If this whole thing here were to be a script file, of course, this is at the top, and then we have our executable code. We're just outputting hello name, you are this years old. And let's go through what an example looks like. You will execute the script by the script name. Here's one parameter and the value you place there. Notice there are spaces here. You'll have spaces between all of these, and then $sign, and then -age for a parameter, 30, and then it would output hello Alice, you're 30. Let's actually just walk through an example here. Let's go through lesson 3. We'll do a new file right here underneath it. We'll call it myscript.ps1. Perfect. Now this already knows it's a PowerShell script based on the file extension of ps1. We'll say param, and then we'll say name and age, and then write output. Actually, we don't even need write output. If you're outputting a string or anything, you can just put it right here. Hello name, you are age years old. Perfect. We will save that. I'll hit Control J to bring my screen back up here, or my terminal. I'll start typing my script, and if I hit the tab key, it should recognize. Actually, I need to get into the correct folder here. And if I start typing mi for my script and I hit tab, it's going to come up and say my script. And that's because it exists here. It'll auto-complete it and find it. If I hit the $sign here and then I hit tab again, it'll auto-complete. It recognizes there's parameters within my script. We'll say Jeff. Age, I'm going to lie here. We'll just say 30 also. And if I hit enter at this point, hello Jeff, you are 30 years old. Great. So that's, if you've never written a PS1 file or a script file, there's your first one. We just walked through it with a couple of parameters, bare bones, bare minimum of what we need to do to use parameters. Let's exit out of this. We'll leave the script file up here for just a minute, and let's go back to our lesson here. Let's talk a few things about best practices. We talked about this before when I talked about variables and whether to use capitalization or not in these. These definitions meet the minimum requirements. There's 2 best practices. First best practice is, this is what I talked about when I reached out to the PowerShell community, asked them about it. They said use Pascal case for your parameter names, where the first word and every main word inside your parameter name is capitalized. So in this case, it's Pascal case P and C. This convention will match what you see inside of compiled PowerShell commandlets, things that other people write inside of C# and they compile it. Should follow that same format. And then you'll want to specify a data type for the parameter. This is the second thing. Data types will help control the kind of input the parameter accepts. We talked about back in the variables lesson that PowerShell is not a strongly typed language. You could create a variable and store a string in it, then convert it to a number, a Boolean value, an object, a hash table array. It doesn't care. It'll keep converting it to whatever data type. But if you define a variable, you can specify this only holds strings, this only holds integer data, etc. You can do the exact same thing with your parameters because they're essentially variables. Let's take a look at our updated example here. We have our param block, and this time in front of our name parameter, we're going to specify it's a string inside of square brackets here, and then age will be an integer value here. This next part is totally your preference. You can put these on the same line of your data type and your parameter name, or you can separate them out here. Each parameter definition that we're going to see will be separated by a comma. So you can see we have our first one here and then a comma, then our second parameter definition there. I prefer this second one here. I don't know why. That's probably what I just first learned when I was writing PowerShell scripts, but I like seeing the data type on its own line and then the parameter name on its own line. But if you were to do this, totally acceptable, no problem with that. Let's actually go back to our script here, because if we go into here, we can, let's do this incorrectly. We'll say 30 and then age, Jeff. It accepts those parameters. Of course, the values are wrong or anything. Let's go in and define our parameters to strongly type their data. We'll say string and then int. We'll save that. Now, if I go try to run this script, it should give me an error. It'll come back, we can't process argument transformation on the parameter age, meaning it probably couldn't convert it to a string or anything like that, and cannot convert Jeff to a number because it's not a valid number. Again, this is sanitizing and making sure the data we get correctly for our script to run is accurate and we won't run into any errors. But now if we go back and say Jeff and then age is 30, that should work out just fine. Now, one thing here is we did input this in like this. Let me do this. If we were to put 30 inside of quotes, we are turning it into a string. We're saying the string 30, not the number, and it'll accept that. Just pointing that out that you can have a number be a string basically if you put inside of quotes whenever you input that data into your parameter value here. Okay, let's get out of this and go back to the first lesson here. Now, so far, again, bare minimum, name of your parameter, suggest strongly typing it with the data, but we do have some additional things that we can do with our parameter when we're defining it inside of the parameter attribute. This is used to define additional behaviors and rules for your parameter. Gives you more fine-grained control. You can make them mandatory. Do they accept pipeline input? So when we have a command here and we do pipeline and then pass that to another command, maybe like get process, stop process, can that parameter accept that type of input? We have validation rules. This parameter attribute gives us a lot of power of what we do within our parameter. There's a lot of different properties. The first one I want to focus on is mandatory. By default, all parameters are optional. What do I mean by that? Let's go back into here and let's bring this back up. I can just run my script, and if I were to run that, it comes back and it runs, but look, I don't have value. There's no name here. It defaulted to 0 here on my integer. That's not correct. I want to make sure if they run the script and I need that information, let's require them to bring it in. And we can do that using the mandatory property. Here is now an updated version of my script where we have parameter. We put this above our data type and our variable name. I forgot my Y here. I will correct that and upload this newer version into GitHub. But first we have our parameter definition here. And inside parentheses, we have mandatory equals our Boolean value of true. That now makes name mandatory whenever we go to run our script. Let's go take a look at what that looks like now. Go here at the beginning and we'll say parameter. Now notice this again, PowerShell extension working. I start typing this and it goes, oh, are you trying to add a parameter attribute here? When this pops up, I can just press enter and it completes it there for me. And then inside the parentheses here, if I were to do control space, it'll bring up some of the properties or things we can set within our parameter. We'll go over some of these later, but I'm going to go down to mandatory. I'm not sure if this is supported in older versions. You can just say mandatory and it automatically sets it to true. You might see older scripts though, or if you're working in older versions of PowerShell, putting equals true is also totally fine. But also know if you just see mandatory, it's saying mandatory equals true. Okay, we'll save that. Let's bring our script back up here. Let's clear the screen. Now, if I go to run my script and I just press enter at this point, we're not specifying any parameters. It's going to come up and say, hey, you have to supply a value for name. I can't run without name. We'll put my name in here, but notice we don't have that for age and it just still comes back with the default value of 0. So mandatory, if you have to provide the information for the script to run, is a great way to force that on anybody who is running your script. Now, parameters are great for providing values to run inside your script, but you can't have default values if you don't provide a value. This will ensure that any optional parameter always has a value, even if you don't specify it at runtime. The example I have here is, say you're writing a script for retrieving log files. You might have a parameter named days to determine how many previous days worth of logs to retrieve. However, if you don't supply a value, just have it default to the last day. That makes sure the script runs successfully. Here's an example of a script file called getLogs. We have our parameter definition. It's going to be integers. I have days here, but just like you declare a variable, in the command line or in a script, we have $days equals to our default value. And then we're just outputting logs for the past days or anything like that. Let's go take a look at what this would look like in here. I know this won't match up in the context of the script, but we are just learning here. So we'll say days equals 1. And we'll say retrieving days log files. Bring this back up here. Now, if I just run my script, so let's go ahead and put in Jeff 30. Now, if I just run this, it should come back retrieving 1 log files. We'll say days log files. Make it make a little more sense. But if I come back and say days 30, we are now retrieving 30 days of log files. Default values, very useful if you want to define specific behavior if they don't provide a value when they run the script. That does it for the end of our first lesson here. Let's go take a look at our exercise. What I want you to try to do is write a PowerShell script named movefile.ps1 that will take parameters for managing files. The script should allow the user to specify a file name of the file you want to move, and then the new file name. This will be optional and provide it with a default value. You'll print the original and the new file name. You don't actually have to move any files. We're just going to pretend like we're doing this inside the script. Test your script behavior by calling it with different combinations of your parameters. And do you think any of the parameters need to be made mandatory? For these exercises, if you're watching one of these videos for the first time, you can pause it right here, go try out this challenge, and then I have a suggested solution right here. So let's go ahead and click on that. Hopefully pause the video and try it, but let's go take a look at what I did for a solution here. So again, taking a first look, we have param, open and close parentheses. My original file name that I want to move is called file name. My new file name parameter also down here. They are both strings, pretty straightforward. Because the point of the script is to move a file, I did make the file name that I want to move mandatory. So that's mandatory equals true. However, changing the name of the file is optional, but I also did provide a default value here if they don't provide it. And then we're just outputting to the screen. I'm moving this file to this new file name. Let's bring up our window here. Let's go into solutions, call this a couple of different ways and just see what it looks like. If I do move file and just run it, file name is mandatory. So I'm going to say text.log, whatever, moving file text.log to move file.text because that's our default value for our new name there. If I run file name, my file.text, and then new file name, old file.text, that'll come up and give us our values there. If you were to go in here and leave off file name, but provide the new file name, it should come back and prompt you for the file name that you want to move, etc. So yeah, just run through multiple ways of calling with the different parameters and see what the behavior is and just get used to what that looks like. Okay, that does it for the first lesson here. Let's get all of this closed up and let's go into validation. Now I've done a separate video on parameter validation. I'll include that again in the playlist here. I'm going to go through this kind of quickly, just showing you the different options, and we have an exercise at the end. Validating your parameter input, we started that a little bit by strongly typing our parameter definition. This has to be a string, this has to be a number, etc. But there are other ways you can also validate what they put in so your script will run as expected. This will prevent errors, it makes your script more reliable. There's several different parameter validation attributes that will check the input and run those validations before your script ever executes. First one we'll take a look at is called validate set. This restricts a parameter and only allows specific predefined values to be put in there. We actually saw an example of this earlier when I was running through the set execution policy. When I got to the policy name, I could hit tab and it brought up the predefined values. I couldn't set it to anything other than bypass, remote signed, and whatever else those values are. If you don't provide one of those values, the script doesn't run. Let's take a look at an example of this. We're going to have a parameter called action, and it only accepts 3 values: start, stop, or restart. We have our parameter definition. We have our data type, string, and action. That's the parameter name. We have our parameter attribute where we're making this a mandatory parameter. And then right below it, we have our new validate set. And we have in parentheses our different values. Since this is a string, it will be the different strings that are allowed for our value here, and then output performing our action there. If you try to put in a value that does not equal any of these, it will come back and say Let's say I tried to run it with pause. Well, that's not one of our actions that we can do. It does not belong to this set, start, stop, or restart specified by the validate set attribute. Validate set, you are making sure they give you the value exactly and only these values. A little bit similar to validate set is validate range. This makes sure that a numeric input falls within a specific range. You can use this to restrict values like percentages, time durations, or resource limits. We use the validate range property here, open and close parentheses, and you have your starting value and your ending value. This is for a parameter named percentage. Maybe you say you're running a script and you want it to only do 50% of a list, 75%, or whatever scenario you can come up with there. Again, you're validating a numeric input that it falls within a specific range that works for your script. Next one is validate pattern. This one is actually very powerful. You can use regular expressions or regex to enforce specific input formats. You could do this for well-known formats like email addresses, phone numbers, file paths, or file names. And I do put a note here, regex can be a complex topic. I'm not going to cover how to write regex or do that. There's plenty of websites out there. I also do have a video where I covered regex a little bit. There's also things like ChatGPT or any other LLM like that. You could probably go into it and say, I need a regex pattern that does this. It'll give you some good example for it. The example we are going to cover here is the format for North American phone numbers. We have 3 numbers, dash, 3 numbers, dash, and then 4 numbers. A regular expression for this would make sure that the number contains exactly 10 digits and it has the dashes in it. To use this inside our parameter definition, we have validate pattern keyword, and then open and close parentheses. And then our regex here, this is saying give me at the start of the string, that's what the caret symbol is there, \D for digits, and then 3 digits, a dash, 3 digits, a dash, and then 4 digits, and then the $sign is end of the string. And I do break that down here a little bit in this, in the paragraph right here. But again, perfect for validating. Maybe you want to make sure that they pass you a file that ends in .txt or .log. You're validating email addresses. Super useful. Next one we can use is validate length. This ensures that a string is within a specified length range. Let's say you have a script for creating a Windows-based server or computer, which has a 15-character limit, but you also want to make sure the computer name has at least 5 characters in it. Here's an example for defining a parameter definition called computer name. We can do validate length, and it can be at a minimum 5 and then a maximum of 15. Validate length, you're just making sure a string is a specific length. The next one is actually probably the most powerful one because you can do whatever validation you want by writing a short script. This custom script will test the parameter value that you provide, and you can use this for checking file paths, maybe URLs, database records prior to running a script. In this example here, we have a parameter called file path. Maybe before you ever run your script or the code that executes below, you want to make sure that this path exists and the file exists or anything like that. We have our validate script keyword here, open and close parentheses, and then we have to include our curly brackets here for our code block. And we are going to use the command test path. Now this $_, we'll see this a lot in PowerShell. This refers to the current object in our pipeline. In this case, that is the value we provide for file path. So you run your script, you say -file path, you give it a value. That value is right here and gets turned into this right here, this $_. The goal of the script that you have inside here should return true or false. It should return some type of Boolean value. In this case, it's going to be test path, and it'll say this test path exists or this path exists. True, it doesn't exist, it will return false. We've seen that a little bit inside of our control flow where we're testing conditions for our if statements or loops or anything like that. In this case, you can also use the throw keyword and throw an error. I did come across some documentation before that says not to use the throw keyword, but instead just return false. This note may be referenced to older PowerShell versions where they used throw with a descriptive error message. It provided more information about why the script or why the value you provided for the parameter passed or did not pass validation. Now, starting in PowerShell 6, if you work with the PowerShell version built into Windows PowerShell, that is version 5.1. Starting in PowerShell 6, which they refer to PowerShell Core and higher, into PowerShell 7, they added an error message argument where you can customize the error message that comes out in reference to your script validation. And inside of this, you can use string replacement syntax of curly brackets and 0 that represents the parameter value that was passed in. Let's take a look at what this means here. Here is an updated example for our file path parameter. We have validate script, our open and close curly brackets here, and then we're adding some additional values. We have our comma, we have error message equals, and we can provide a nicer error message and saying the file path this. Again, this represents our file path that we passed in. We're not using $_ in this case, is not valid or does not exist. This just gets into a preference thing at this point of how compatible you want your script to be. If you're absolutely sure your script is going to be used in PowerShell 6 or higher, just return false within your validate script property and use the error message to describe why it failed. Otherwise, use the throw keyword. Overall, for you just getting started, just focus on whether or not your script in here returns true or false. Sometimes you actually have to use the return keyword in true or false. But in this case, for something like testing path, you're going to run test path. Does that path exist? True, false. And it'll put that out for you. You could do, if you do something else, I'm trying to think of a scenario where you wouldn't want to run a comparison and return true or false. Maybe you don't want to use regex. So you say, well, even then you say, file name like this or not like this, it'll return true or false. So anyway, most things I feel like you would do inside of your validate script here would return a true or false evaluation. Next, let's talk about validating for not null or empty strings. I think this is pretty powerful. I don't use this that often, but it's definitely here if you need it. You can validate your parameter value as not null or an empty value or an empty string by using validate not null and validate not null or empty. In this case, you don't necessarily care what the value is as long as the user provided a value. Let's actually experiment with something here real quick. I'm going to open up my script again. And we know name is a mandatory field. So let's open this up. We'll just go back up here. And if I hit enter at this point, okay, so it comes back and still says it's an empty string, but we made it mandatory. So maybe you're in a situation where you don't have a parameter that's mandatory, but you want to kind of make sure it's not an empty string. That would be an interesting scenario. Let's take a look at our different methods here. We can say validate not null. It does prevent null values, but does allow empty strings. And validate not null or empty, it prevents both null values and empty strings. In this example, it will allow an empty string, but not allow it to be null. So we just have validate not null attached to our parameter definition here. And then here we have to make sure it's not an empty string or null. Let's actually go back to the my script example. I was just thinking about, I think I just had an idea here. So let's run my script again. I need to go back one. Let's run my script. Now what I could do here is open and close parentheses. I'm saying this is an empty string and it will work because it took this, whatever is inside of here. So that's not quite what we want. We could get by not providing a value, but it's still not super nice there. If I run my script and we'll say name and I do an empty string. Okay, it didn't allow an empty string there. So let's go back and take a look here at our validation. This allows an empty string, but not null. So let's do validate not null. Here we're going to define it. If I start typing out validate, we can see a bunch of other different parameter validations we can use, but we will say validate not null attribute. Let's try to run this again. Interesting, it's not allowing me to do that. I was expecting to be able to come in and do that. I'm guessing since it's mandatory, so let's take mandatory off here. And let's go back and run one of these there. Since it's mandatory, it's making sure it's doing some validation there for me anyway to make sure it's not an empty string because I put it as mandatory. In this case, we are not a mandatory parameter and we are allowing it to be an empty string. Let's say if I do specify this null or empty, and I try to do this here, it's going to come back and say that's not allowed. This would be an interesting area. I don't know how much this will be used for you, but just know it is available when you're working with your string values. Okay, that brings us to the end of lesson 2 here. Let's talk about our exercise that we want to cover. We're going to look at creating a new user script. We're going to write a script for creating a new user with these following parameters and validation. We want a username that is 5 to 12 characters, a password expiration between 30 and 90 days, and then an email address. I give you a hint here. We talked about this earlier. Just go find a regex pattern to match an email address. Go ask ChatGPT, Gemini, whatever LLM, or just do a Google search or your favorite internet search engine to go find an example of what regex looks like. You will display a message confirming the user's account information. Again, you don't have to actually go create any type of account. Just output the information and then test your script with some different parameter validations. Again, pause the video, give this a try, and whenever you're ready, let's go take a look at my suggested solution. Here we have our parameter definition again. We have validate length for our username. We want it to be between 5 and 12 characters in length. We have password expiration days. This is an integer value, so we're going to use validate range between 30 and 60. Then we have validate pattern for our email address. This is the start of the string. I don't remember exactly what all these mean, but between our square brackets here, we are essentially saying, I think, accept any character, or maybe even dashes and everything. And then we're going to make sure we have an @ symbol, allow any characters, dashes, which probably wouldn't work great for an email address, but this is very basic. But we're doing this part and then a dot at something else. This breaks down to the username at something dot something. So jeff@jeff.com, whatever you want to call it there. And then just using write output, we're going to say new user account details, the username, the email, and the password, and output that to the screen. Let's take a look at what this would look like. Give us some more room here. Let's run create user. Now, if I were to run it without any parameters, it's going to come out and not give us any information. So that's not super helpful. We could maybe make some changes to this, make some parameters mandatory and everything. But let's go through and run it as it's intended. We'll say username, J Brown, password expiration days, we will say 45. And that ran through. Hit enter too soon, and we'll say the email is jeff@me.com. And that works as expected. So let's go through and break some of these and verify our validation works. We want it to be between 5 and 12 characters. So if I were to say jbro, that's going to come back. We can't validate this. Your link that you provided 4 was too short. It needs to be greater than or equal to 5. Let's go through and make it longer than 12. Needs to be less than or equal to 12. Perfect. So that is working as expected. Let's go back up to a good example here. We have password expirations. If I were to do 14, that should come back. Is not allowed within the range. Perfect. If I were to go to 91 days, nope, that doesn't work either. Okay, so let's go back to a good example here. And then an email address, let's say jeff@me, and we did com. That should fail and say, oh, I did not have my good username here. So let's go back into here. Now, this isn't super helpful. I believe these validation methods do have their own error messages, just like we saw with our script, where you can come back and say your email address format should look like this. In this case, it's just saying you don't match this regex value, which if someone were to look at this, they'd be like, I don't know what that means. But some of these, I think you can also provide your custom error messages, but that's probably in PowerShell 6 or higher. And again, if we wanted to make this a little bit better, we want to verify our parameter. We want to say mandatory. We'll toss in here equals true. And then again, maybe we don't make password expiration mandatory, but we can auto set it to 60 with a default value. And there's some other things here. This isn't quite validation, but let's say if we don't provide an email address, so let's say not email, we learned about how to check for empty strings or anything in earlier lessons. We can say email equals username. We can reference our parameters when setting other values. We'll say me.com. We'll put this inside of strings, some double quotes here, so we get some PowerShell variable expansion. So again, just a couple other things here we can work with. Let's clear out the screen. We'll run create user, say username J Brown. But if we just leave it at that, we'll get a default value for our expiration day of 60 days, and it'll automatically create our email address for us. Just some extra things there. As you're working through these exercises, you might, if you want to challenge yourself a little bit, see how you can go beyond the exercise just a little bit and add some additional things there. Okay, that does it for this lesson. Let's close this out and get this cleaned up here. And let's go take a look at switch parameters. Switch parameters are a special type of Boolean parameter that doesn't require an explicit value whenever you use them when calling your script. Instead, the presence of that switch just means it evaluates to true and is set to true. If you don't admit it, it defaults to false. You can use switch parameters for simplicity, for making decisions inside of your scripts when you call them. And then they provide clarification or clarity when they exist. That means, you're set to true, and that's a binary choice, such as turning a feature on or off. Switch parameters are defined pretty much the same as we've seen with our other parameters here, but their type, we've been working with them like string, integer, etc. They are of the switch type. You don't have to require a value when you call them. Let's take a look at what this would look like here. We have our parameter definition. We have the switch type, and the name of our parameter is verbose mode. Now, if you know about PowerShell, there is a -verbose that's included with commandlet binding. I absolutely understand that. This is just for example purposes. This is what I thought of when I was working with this or coming up with this example. And then inside of our script, we have if. We have if verbose mode. If you called the script with -verbose mode, that means it is equal to true. In this case, we're saying if true. We learned about this with our if statements. Then we'll output verbose mode is enabled. Otherwise, verbose mode is disabled. If you were to run this script and just specify -verbose mode, so my script and -verbose mode, notice there's no value here that we provided into the parameter. Just its mere presence means verbose mode is set to true. The script will output verbose mode is enabled. If you were to call it and not include this, it will say verbose mode is disabled, because if you didn't include the command, it defaults to the value of false. What are some best practices? If you're going to use switch parameters, make sure you have a very descriptive name. For example, -force. This will force the action. You're not going to include a prompt or test mode. This clearly communicates their intent and what they're going to do. Make sure you design your script with default behavior in mind. So if you omit the switch or you don't include it, it will execute in a default or safe way, only enabling specific behavior when the user provides the switch. So an example there is force. Maybe there are situations where you don't want to force delete something to recreate something new, but there are situations where you do. You don't want force to be the default. If they add force in there, then it's going to take that destructive action inside of the script that you're writing. You can also combine switch parameters with other parameters. For example, a switch could control whether the script should log output to a file in addition to the standard output. This is something I've done before. or maybe I'm working with something, I just have it output to the screen, but then I do a dash enable logging or something like that, and it'll also write it out to a file for me. Let's take a look at an example of what this might look like for a script that would process files. We have our parameter definition here, and we have our first parameter here called file path. It is of type string, so we're going to pass in a path to the files that we want to archive. And then we have a switch. So we pass in the file path to files that we want to process, and then do we want to archive it or not? We have that as a switch parameter. Some of the first things we'll do, we could have included this inside of our parameter validation in our script that we just learned about. But in this case, I'm testing to see if this path is valid or not. If it's not, we're going to output that the file was not found. We'll output to the screen that we're processing this file. And then we're saying if archive. If I call this script with -archive, that means archive equals true. If true, we are going to say we're archiving the file, and then maybe there's a command down here to move it to another destination. Otherwise, we are just going to output processing complete, and the file remains in its original place. Just a small idea of what you could use with these switch parameters. In this case, do you want to process something and then archive it, or maybe you just want to process it and then leave it where it is originally? I do have a quick recap here since there's no exercise with this one. Switch parameters are Boolean flags. They are true when you include them inside of calling the script, false when they're omitted. You do not have to provide a value if you include it. So example -archive, we don't have to include any value here after it. You can use it to toggle behavior, such as verbose output, performing cleanups, skipping prompts. The default behavior, if you don't include it, should be safe. And then if you include your switch parameter, it does those optional things, or maybe takes that destructive action more intently, like a dash force or anything. Use your descriptive names and combine them with other parameters to add flexibility and make the script more dynamic. Finally, that brings us to our last lesson here. Let's close this out and go into just some miscellaneous things about parameters to think about when you're going to be including these inside of your script. Now, the things we've just talked about are some of the core concepts, but there are some smaller features and things you can use to make your scripts more user-friendly with your parameters, make them more flexible. You can include aliases, parameter ordering, and working with arrays and hash tables. Let's take a look at that. The first one is alias. We do know about aliases already inside of PowerShell. We learned, the for each -object has an alias of for each, and also the %sign. These are just other names for things that have other than their official name. You can do the exact same thing for parameters. You're defining alternate names for your parameters, and it can make your script easier to use and reduce typing for common parameter names. You can provide shorthand versions. So instead of -username, you can just say -u. There might be multiple ways somebody might refer to something. So you might say file path, but they might think of or just want to use -path. Including aliases maintains compatibility if you go back through and refactor your script. With our parameter definition, we just use the alias keyword and include other strings here of what our parameter could be. So username or -u or -user. Here are some examples of what that would look like if we could call it my script. And again, with each different example, they're all referring to the same thing. Next thing to consider is your parameter ordering. Parameters can be passed by name or position. What do I mean by that? Let's take a look at the new item commandlet. You can call new item and specify the path using the path parameter like this. You can say new item, path. I'm making this folder temp off the root of my C drive. However, you can accomplish the same thing without specifying the path parameter. You can just say new item and then the new item that you're creating. However, how does PowerShell know to take this value that you provided here, and how does it know that it goes to the path parameter because we didn't specify it here? Path has been given a position inside the parameter definition. If you ever want to know the positions of parameters inside of compiled scripts or functions, if you run git help and then the commandlet that you want the help on, and then specify the parameter path, here is what that looks like inside of there. Here is our parameter definition. We know it's not required. However, its position is 0, meaning if you don't specify it, PowerShell will take the first value inside of the command that you run there, just like we saw here, new item, and it will assign it to your path. The next thing about defining a position is by default, PowerShell will autocomplete parameters based on the order that you define them in your script or function, but you can override this by providing a position value. In this case, think about our my script earlier that we wrote. The first parameter we defined is name and then age. If we didn't include a position number here, as we saw, as I went through to use the command, if I did dash and hit tab, it brought up name first because I defined it first. And then after that, it would be age. However, I could swap these and say this is 1 and this is 0. And when I hit dash and then tab, age would come up first because we changed its position to being 0. Same thing for when we call the script. Right now, this is position 0 and position 1. If I call script, I pass in Alice and then 30, it's going to assign Alice to name. And then 30 here because that's the order they are set in here, and that's the order that we provide the values. Let's see what this looks like a little bit more. Let's bring back up my script here that we were writing before. Okay, let's take out some of these extra things here. Let's clean this up. Now we have our name. Let's just say position. We'll be explicit first and say position equals 0. And then position equals 1. This should act the exact same that we saw before. So if we do my script, I hit dash. Now I hit tab. Name's going to come up first because that's in position 0. We'll say Jeff, and I hit dash again and hit tab. It'll come up with age. Perfect. Let's take out our other statement here. But if I were to go through and just say my script and say Jeff and 30, it automatically knows, okay, this first value here, after calling our script file, that is going to go to name because that's in the 0, and then 30 will go to age. However, we could swap these. Now, if I were to try to run this again, it should error out because we are strongly typing our parameters there. But if I do 30 and Jeff now, it's going to correctly assign them where it needs to go. You are 30 years old. 30, let's back up. This 30 here is the first one we provided, so that's going to go to 0. And then Jeff is going to go into 1 here based on our position definitions. This is only important if when you're defining your parameters here, you don't put them in the order that you think the person running your script should do them in. In this case, name and age, it doesn't matter. But maybe you're doing something like copy item. If I do copy item, the first one is going to be the path. What do we want to copy? Let's say my script. And then the second one is the destination. That kind of makes sense. I'm copying an item. I want to copy this one to this destination here. So we'll say like my script 2.ps1. And we can see that automatically created right over here and copied it. But again, I don't have to specify the parameters. If I were to say my script again, and my script, we'll say 3 this time so we can actually see it work. It automatically knows that this is my original one that I want to copy, and this is where I'm copying it to. Okay, that does it for parameters. It's more of an introduction than what I've done in other videos. That's why I wanted to go over the basics here. I'll include other videos I've done in the past inside the playlist that go deeper into some of these topics. But let's go take a look at our challenge for this module. In this case, I'm not having you write a PowerShell script and starting from scratch with your parameters. I want you to start thinking about what parameters I could use in scripts as you're writing them. In this case, I'm going to give you a script with hard-coded values in it, and I want you to recognize and see which ones are in there and turn them into parameters. This original script performs a basic file operation. It will rename a log file and move it to a backup folder. It's very rigid right now, though, because we're hard-coding values in it. What I want you to do is refactor it and write in some parameters, put in whatever validation attributes you think would look there, maybe some switches if you think that is appropriate. Here are the requirements For each parameter, verify the source path exists, provide default values, specify that the new name ends in txt, and allow the option to overwrite if the file exists. And then inside the script logic itself, it's already written out for you, creates the backup folder. If it does not exist, now it puts a message if the option to overwrite is enabled. Now you don't actually have to move files and rename things and everything. Just output to the screen what the script is doing. Don't want you to have to accidentally modify your system in some harmful way. Hopefully by the end of this, we will have a refactored script that would look something like this. The name of the script is move log file. We have a parameter for source path. We give it this source log file here, the new file name. Do we want to override it or not? And what is our backup folder that we're probably sending it to? Let me scroll down a little bit more. Here is the original code that I want you to copy into a PS1 file and then start refactoring it. We have some hard-coded values here. That should be a big tip-off that this is a good idea to sort into parameters. And in general, the rest of this logic, I can't remember how much of this we change or not, but probably not much here. You're just switching a lot of this into parameters. So take this code here, put it into a PS1 file. If you want to pause the video and work through the exercise, and let's go take a look at my suggested solution here. Okay, so let's take a look at the parameters that I wrote here. We have source path. I put a parameter that this is mandatory. We're going to use validate script to verify that the source file exists. It's of a string value. We have another parameter here for the backup folder. Where do we want to send this to? We're going to make sure it's not null or an empty value that they're providing here. Probably also do the exact same thing with validate script, making sure the path exists. But I believe further down, we have logic to see if this backup folder exists or not. If it doesn't, to create it. So that's why I probably did validate not null or empty. I did put a default value in here just for fun. Then we have new file name. Again, this is going to be mandatory. What do we want to rename the file to? I want to make sure that it ends in .txt. So I found some regex here. Notice we don't have that caret symbol here, meaning not the beginning of the string, but this is the end of the string, .txt with the $sign. That's going to be our new file name. So making sure it ends in .txt. Then I have a switch parameter saying overwrite. Do I want to overwrite any existing destination files? I created another parameter here, Boolean value called move file equals true. First, let's ensure the backup folder exists. You can simulate the creation. We're not actually going to do it here. We're going to test the path to see if this backup folder exists. If it doesn't, backup folder does not exist. We will simulate creating it. If you want to challenge yourself, actually go through and create the destination folder. But in this case, we're focused on parameters and everything. We're going to build our destination path. I did this. This is a new command I actually came across. I've been working PowerShell forever and I did not know about join path here. But what it does is you can take something like your backup folder path and then correctly make a full file path out of it and then say child path and then your new file name. So in this case, our backup folder, let's say it defaulted to C backups, and then you provide a new file name. It will put that all together into one string. I used to just, create new variables and stuff, but I like the join path because it's a little more PowerShell official. You're going to check to see if the file already exists. So we are going to test the path on our destination path variable we just created. We're going to output if the file already exists in the destination, but did we specify overwrite? If overwrite is true, meaning it's a switch parameter, we included it inside of when we called the command. We just say we're going to overwrite the file, else we are going to skip the file because it already exists. And move file is false. So we're not actually going to move it because it already exists inside the destination. Finally, we're going to check the value of move file. We originally set it to true. So in most cases, we are going to move the file unless we did not specify overwrite and it already exists. I think I went a little too deep in the logic here. So sorry about that if that's a little too confusing. But if move file ends up being true, we are going to move the file. Again, I think the primary thing I want you to focus on is taking some of these hard-coded values here and then putting them into parameters here, I went a little bit further and changing a few things around. Not required, but I would want you to look at a script like this and go, hey, why are these hard-coded values here? Let's turn these in parameters. And that's really what I want you to focus on, is taking those and then thinking about how can I sanitize or make sure the input I get is valid and correct for my script to run correctly. All right, but yeah, that does it for parameters. I'm going to include some other videos in the playlist going deeper into parameter validation and, defining parameters and all that fun stuff there. But anyway, thank you for watching this video. Stay tuned for more in this series on PowerShell command line to scripting, and we'll see you in the next video.